Good evening, everyone. This is Navin sir, DRS Academy. Today we'll discuss increasing, decreasing functions.
Right. Say this increasing, decreasing functions. So here increasing function means, for example, you see the curve x-axis, y-axis, x dash, y dash. When you are taking the curve, this curve continuously increasing, and the second one is sometimes increases, constant, increases, constant, increases, constant. So both are the curves increasing only. Both are increasing only. Okay, na? What is the difference here? Here the curve continuously increasing. Continuously increasing. Here sometimes increasing, sometime increasing, sometime constant. Okay, na? Sometimes increasing, sometimes constant, increasing, constant, increasing, constant will be like that. So, for example, if I am taking two elements, so this is x1 and here x2, two elements. What is the relation between x1 and x2? What is the relation between x1 and x2? X-axis, no, going right side, the value will be increases. x1 is less than x2, correct? If I replace this value into the function, so I will get this is f of x1. What it is? F of x1. If I replace this value here, then I will get here f of x2. Then what is the relation between f of x1 and f of x2? On y-axis going upside, increases. What is the relation between these two? F of x1 is less. F of x1 is less than f of x2. Okay, na? So this is condition for when it is continuously increasing, that I call as strictly increasing. What it is called? Strictly increasing. Clear, no? So x1 is, what is the condition for strictly increasing? X1 is less than x2. F of x1 is less than f of x2. Then it is called strictly increasing. The second case, what is the second case here? Suppose you see here, I'm taking three elements. One is x1 here, and one is x2 here, and one is x3 here. X3. What is the relation between x1, x2, x3? X1 is equals to x2. Sorry, x1 less than x2 is less than x3. X1 is smaller than x2 is smaller than x3. Function values. F of x1, f of x2, same. F of x3 is different. F of x3 is different. Yes, no? So what about the function values? So f of x1 is equals to f of x2, which is less than f of x3. Suppose if I combine these two, suppose if I am taking these two, x1 is less than x2, x1 is less than x2, function value f of x1 is equals to f of x2. Suppose if I am taking x1 and x3, x1 is less than x3, function value f of x1 less than f of x3. Following that? So if I combined these two, x1 is less than x2, then function value may be lesser, or maybe equal, less than or equals to f of x2. Here, when you are observing the difference, only less than comes, it is strictly increasing. Strictly increasing means always increasing. Here, x1 is less than x2, f of x1 is less than f of x2, it is increasing, just increasing. Means overall the graph is increasing. But not continuously increasing. When you are observing here, the graph is continuously increasing. Here it is increasing, constant, increasing, constant, increasing, constant. Means sometimes increasing, sometimes constant. But when you are observing overall the graph, overall graph is increasing. Okay, na? So it is strictly increasing, it is increasing. What is the condition for strictly increasing? X1 is less than x2, f of x1 less than f of x2. What is the condition for increasing? X1 is less than x2, f of x1 is less than or equals to f of x2. Only difference is less than or equals to. This is one condition. Okay, na? And come to the decreasing. Come to the decreasing. Decreasing also two types. Decreasing also two types. One is strictly decreasing. Strictly decreasing. Second one is decreasing. Same like the previous one. So strictly decreasing means always decreasing. Strictly decreasing means always decreasing. X-axis, y-axis. So when you are observing this curve is continuously decreasing. If I observe the second curve, the second curve is x-axis, y-axis. So decreasing, constant, decreasing, constant, decreasing, constant. Overall the graph is decreasing, but not always decreasing. Sometimes decreasing, sometimes constant, sometimes decreasing, sometimes constant. So here, then how? The same thing here. I'm taking two elements. x1, x2. x1, x2 are the two elements in the given domain. So what is the relation between x1 and x2? x1 is less than x2. x1 is less than x2. So here function value, if I replace the x1 into the curve, I will get this is f of x1, and I replace the x2 into the curve, I got this is f of x2. F of x2. Now tell me, what is the relation between f of x1 and f of x2? F of x1 is at up, x2 is down, y-axis going upside increases. So what is the relation between these two? F of x1 is yes, greater than f of x2. Correct. F of x1 is greater than f of x2. So means the sign is reversed. Then it is a strictly decreasing. Strictly decreasing. Suppose if it is the same sign, x1 is less than x2, f of x1 less than x2, f of x2. Same sign, strictly increasing. Opposite sign, strictly decreasing. Then what about this one? Here the same thing. So here x1 and this is x2 and somewhere this is x3. When you are observing here, x1 is less than x2 is less than x3. What about the function values? F of x1 is equals to f of x2, which is greater than f of x3. F of x3. X1 is here. When you are observing, x1 is less than x2 is less than x3. But function values, f of x1, f of x2, same. x3 is smaller. F of x3 is smaller. Okay, na? So together what we can write here? So x1 is less than x2. That implies f of x1 is maybe greater or equal. To f of x2. Understood? So reverse sign is strictly decreasing. Reverse sign with equals to decreasing. Okay, na? It is just decreasing. Now, so this is the standard condition. Okay, na? Here I am writing. Whatever the four formulas I said, I am writing here. So let x1 comma x2 are the two elements in the given interval, any interval I, such that so x1 is less than x2. That implies f of x1 is less than f of x2. F of x is strictly increasing. Okay, na? First point. Second point is the same thing. Let x1 comma x2 are the two elements in the given interval such that x1 is less than x2 x1 is less than x2, that implies f of x1 is less than or equals to f of x2, then f of x is increasing. Okay. Third point. What is third point? Let x1 comma x2 are the two elements in the interval I, comma, if x1 is less than x2, that implies f of x1 is greater than f of x2, then f of x is strictly decreasing. Let x1 comma x2 belongs to I. If x1 is less than x2, that implies f of x1 is greater than or equals to f of x2, then f of x is decreasing. Okay na? So if f of x is strictly increasing, f dash of x is greater than 0, we will use this one. If f of x is strictly increasing, you can use this one, your wish, but it is comfortable for us. F of x is strictly increasing, f dash of x is greater than 0. If f of x is increasing, f dash of x is greater than or equals to 0. Okay na? If f of x is decreasing, f of x is strictly decreasing, f dash of x is less than 0. F of x is decreasing, f dash of x is less than or equals to 0. Is the answer. See the question. Show that f of x is given by 3x plus 17, where 3x plus 17 is a strictly increasing on R. They're asking to prove that it is strictly increasing on R. I can do two methods. Okay, na? Method 1. What's the method 1? What I want to prove strictly increasing? Strictly increasing means x1 is less than x2. That implies f of x1 is less than f of x2. Correct? Strictly increasing formula. x1 is less than x2. F of x1 less than f of x2. Yes, I'm taking x1 is less than x2. So the given question is f of x is equals to 3x plus 17. F of x1 is equals to 3x1 plus 17. F of x2 that equals to 3x2 plus 17. Okay na? So consider x1 is less than x2. I'm taking x1 is less than x2. I want to prove that f of x1 is less than f of x2. See, x1 is less than x2. What I want the answer? I want the answer in terms of 3x plus 17. Multiply both sides by 3. Multiply both sides 3. Then what it is here? 3x1 less than 3x2. 3x1 less than 3x2. Add 17. 3x1 plus 17 less than 3x2 plus 17. 3x1 plus 17 is nothing but the f of x1 less than f of x2. See here, what I took here? I took here x1 is less than x2. What I got the answer? F of x1 is less than f of x2. Then f of x is strictly increasing. Okay na? So what is the method 2? Method 2 is easy, but you cannot do for 2-marker question. It is use it for MCQ. What they given here? F of x equals to method 2. F of x equals to 3x plus 17, right? What I given? Method 2 here. When f of x is strictly increasing, f dash of x is greater than 0. I want to check whether f dash of x is greater than 0 or not. So differentiate it. When I'm differentiating f dash of x, what is f dash of x? Derivative of 3x, 3. Derivative of 17, 0. F dash of x, 3, which is greater than 0. F dash of x is greater than 0. Therefore, f of x is strictly increasing. Okay, na? If you are doing like this, they will not give for you 2 marks question. See this. What is the question? Find the interval in which the function f is given by f of x equals to 2x cube minus 3x square minus 36x plus 7 is strictly increasing, strictly decreasing. Where it is strictly increasing, where it is strictly decreasing. The same concept. What is that? We should find f dash of x. Okay. So solution, f of x is given f of x. What is f of x? F of x equals to 2x cube minus 3x square minus 36x plus 7. Differentiate it. Differentiate with respect to x. F dash of x. F dash of x equals to 2 times of derivative of x cube 3x square minus 3 times of derivative of x square 2x 36x. 36 into 1, 7, 0. So f dash of x. F dash of x equals to 6x square minus 6x minus 36. Okay, f dash of x. What is given the concept? When f of x is strictly increasing, when f of x is strictly increasing, when f of x is strictly increasing, f dash of x is greater than 0. F dash of x is 6x square minus 6x minus 36 is greater than 0. Take 6 common, x square minus x minus 6 greater than 0. Send 6 that side. It's a positive number, no? It will not be affected. X square minus x minus 6 greater than 0. So find the factors for this. What are the factors? Multiply quotient of x square and 6. 1 into 6. That equals 6. 6 which table will go? 1 6 2 3 3 2 6 1 the same thing. Here the second sign says that subtraction. Subtraction is 1. Which subtraction is 1? This is. So x square. Here whatever the sign, that is give for the biggest one. Minus 3x plus 2x minus 6 greater than 0. Taking x common, x minus 3 plus 2 common, x minus 3 greater than 0. So x minus 3 into x plus 2 greater than 0. Okay, na? I got two factors. X minus 3 is equal to 0, x value 3. And the second one is x plus 2 is equal to 0, x value minus 2. These we call as critical points. What is that? Critical points. So for finding the interval, so present these critical points on the number line, small to big. It is x-axis. X-axis. X-axis, how the values will be? Go small to big. So small value, big value. So take plus, minus, plus. Why plus, minus, plus? The graph, see, it is a quadratic polynomial, right? The graph of the quadratic polynomial is parabola. Parabola. So here left side of this value is curve is above the x-axis. The right side of this point is above the x-axis, means positive. The curve is positive. Here the curve is positive. The curve is negative between the two values that I said here. So left side is positive. Right side is positive. The curve is negative between 2 and 3. What I want here, the curve is greater than 0. Where it is greater than 0? F dash of x is greater than 0. They are asking, this is the curve, f dash of x. F dash of x is greater than 0. Where the curve is greater than 0? The curve is greater than 0 for x belongs to, the curve is greater than 0 for x belongs to, where it is positive. Greater than 0 means positive. Where it is positive, less than minus 2, greater than 3. Following that? So x belongs to minus infinity to minus 2, union 3 to infinity. So here f dash of x is greater than 0. F dash of x is greater than 0 means f of x is strictly increasing. F of x is strictly increasing for x belongs to minus infinity to minus 2, union 3 to infinity. They are asking second question, where it is strictly decreasing. Okay, first question is over. Second question, where it is strictly decreasing. F of x is strictly decreasing. B. if f of x is strictly decreasing, f dash of x is less than 1 minute. So f dash of x is less than 0. So here it is the same thing. F dash of x. What I got f dash of x? This no. This is f dash of x. F dash of x is x square. Same thing. X minus x plus 2 x plus 2 into x minus 3 is less than 0. So same thing. Here minus 2 plus 3, right? So plus minus plus. Where it is negative? It is a negative between 2 and 3. F dash of x is less than 0 for all x belongs to open interval of 2 to 3. Understood? Where it is negative? Between 2 to 3. F dash of x is less than 0, negative for all x belongs to open interval of 2 to 3. F dash of x is less than 0 means f of x is strictly decreasing. For all x belongs to minus 2 to 3. So all the questions are same model. Okay.
We see the second question. Y is equal to log of 1 plus x minus 2x by 2 plus x, where x is greater than minus 1. They are asking, show that it is increasing function throughout its domain. What they given here domain? Domain is x is greater than minus 1. Domain x is greater than minus 1. That means open interval of minus 1 to infinity. Now, let's see this. Y is equals to log of 1 plus x minus 2x by 2 plus x. They are asking, show that it is increasing function. We know that for increasing function, what it is? F dash of x is greater than 0. Yes, find the differentiate with respect to x, y dash or else f dash of x, both are same. Derivative of log x, 1 by x means here x means 1 plus x, 1 by 1 plus x into derivative of 1 plus x, that becomes 1 into here derivative of, it's a u by v formula. What is the formula for u by v? U by v whole dash is equals to v u dash minus u v dash by v square. So here v 2 plus x into derivative of 2x, 2 minus 2x into derivative of 2 plus x, 0 plus 1 by v square 2 plus x whole square. Following, right? Then y dash is equals to 1 by 1 plus x minus, let's simplify this here, 2 to the 4 plus 4x minus 2x minus 2x by here 2 plus x whole square, 2 plus x whole square. Then what it is here, y dash is equals to, once check it ma, is it correct? Right ma. See, this small correction is here. This is 2x now. So 2 to the 4, 2x minus 2x. Then what it is here? Do the LCM. Here 2x cancel. Do the LCM. If you do the LCM, it is a 2 plus x whole square. Then it's a 2 plus x whole square minus 4 into 1 plus x. 4 into 1 plus x. When you simplified here, y dash is equals to expand a plus b whole square. 4 plus 4x plus x square minus 4 minus 4x by 2 plus x whole square. 2 plus x whole square. Denominator here also 1 plus x is there, no? 1 plus x. 1 plus x. LCM is nothing but just like cross multiplication. So that here 2 plus x whole square, 4 times of 1 plus x by 1 plus x into 2 plus x whole square. Here minus 4, 4 cancel, 4x cancel. Y dash is equals to x square by 1 plus x into 2 plus x whole square. Till here it is okay, fine. Then what it is? They said, show that it is increasing function. If y is increasing or else f of x is increasing, f dash of x is greater than 0, y dash is greater than 0, means x square by 1 plus x 1 plus x into 2 plus x whole square must be greater than 0. Very good. See here, this is a function. This is a function. Here 3 terms are there. Numerator 1 term, denominator 2 terms. I want the answer is greater than 0, which means a plus. So clearly the numerator says that square, it says that positive, and the denominator, the second term is also square, it is also positive. So the result is depends on whether it is positive or negative. The result is depends on the term 1 plus x. The term 1 plus x. Suppose 1 plus x is negative. What is my answer? So it will come negative. Suppose 1 plus x is positive, then what it is the answer? Positive. So here y dash is greater than 0. If y dash is greater than 0, then 1 plus x must be greater than 0. Means x must be greater than 1. So what we understood? So if x is greater than minus 1, then f dash of x means y dash is greater than 0. Y dash greater than 0 means f of x is strictly increasing. That they are asking. Okay, na? What they are asking, see the question here. So the function is, show that the function is increasing function throughout its domain. What they given the domain? Domain they given as x greater than minus 1. Yes, we got it. So f of x is strictly increasing. F dash of x greater than 0 means f of x is strictly increasing throughout its domain. Yes, ma'am.